Okay, so people have been wondering if we're alone in the universe, right? We've been looking at stars, thinking about life on other planets and faraway galaxies, and guessing about all that. Well, word is that the head of NASA said the James Webb Space Telescope, our best tool for looking at space, found something pretty cool. Get this, they might have found life on Proxima b. This could flip everything we know on its head. Let's check out what the Webb telescope found and what this Proxima b discovery could mean for us and space stuff in the future. The James Webb Space Telescope is like a super cool piece of tech that can change how we see the universe. It's got fancy stuff that lets scientists check out stars, galaxies, and planets in ways we couldn't even dream of before. It gives us a way better view of space. And honestly, it's not an exaggeration to say that its technology is awesome. One of the best things about the Webb telescope is its giant mirror. It's way bigger than the one on the Hubble Space Telescope. This helps it gather even the dimmest light from super far away, even places other telescopes couldn't see before. Before, scientists just had ideas about what was out there, but now they can actually see it in detail with the Webb telescope. It also has instruments that can see different types of light. One of them, called NIRCam, takes pictures using infrared light. This is helpful cause infrared light can go through dust clouds, so scientists can see deeper into space. With its high resolution, NIRCam helps us watch how stars are made in galaxies. Basically, the goal is to learn about the early universe, where galaxies come from, and find planets that we couldn't reach before. These tools show smaller details about how the universe is put together, helping us figure out how galaxies grow and change. Another tool on the Webb telescope is NIRSpec. It breaks down light from space stuff into colors, which gives us info about how hot it is, how fast it's moving, and what it's made of. It's like it lets scientists zoom in on stars and galaxies to see what they are composed of and how they react with each other. It also helps us understand how stars and galaxies live and die by showing us how they're born, how they grow, and how they end up. One of Webb's big jobs is checking out super far-off galaxies. By taking a closer look at the colors in their light, we can tell how old they are, what they're made of, and more. There is also MIRI. It helps us check out longer wavelengths of infrared light to examine things like stars, planet systems, and dusty areas where stars are born. MIRI also lets us look at the air around planets and learn about what's in them, how hot they are, and if they could have life. The places where stars are born are super interesting. These big clouds of dust and gas block regular light, but infrared can pass through. Because of MIRI, scientists can watch how stars and planets are made and study what happens in those areas. MIRI even detects gases like water and carbon dioxide that could mean something might be living there. To look for life on other planets, the Webb telescope uses colors in the light and studies the air around the planets. Spectroscopy is a fancy word for breaking down light to see what stuff is made of. When a planet passes in front of its star, Webb can spot starlight going through the planet's air. Webb can then spot what the air is constructed from, spotting molecules that could be a sign of life. Webb employs MIRI for mid-infrared light and NIRSpec for near-infrared to do the job thoroughly. When starlight passes through a planet's atmosphere, it changes a bit, and Webb analyzes those changes to see what the atmosphere is made of. By finding specific clues in the light, scientists can build models to understand the atmosphere and climate of the planet. One of the big goals of Webb is to find things like oxygen, methane, and water vapor, which are connected with life. But finding them is only the start. There's still more to learn about whether a planet could actually support life. Another useful way to determine what is on other planets is an approach known as comparative analysis. So, what do you think about all this? Drop your thoughts down below. And if you liked this video, be sure to hit that like button and subscribe. Catch you in the next one. The James Webb Space Telescope has completely changed planet searching. It can spot clues of life in the air around planets. As scientists dig into the information they have gathered, they learn new things about the possibility of life elsewhere. The Webb telescope's ability to see super far away lets us look back in time and watch the early stages of the universe. By spotting light from galaxies that were formed billions of years ago, Webb gives us a unique chance to study how the universe grew up. It gives us valuable information about how stars, planets, and galaxies were made. Besides searching for life, the James Webb Space Telescope also helps us understand space in general. As the telescope continues to surprise us about space, it constantly shifts our views. Looking ahead, the Webb telescope will continue to explore all facets of our universe. Its discoveries could have huge effects not only on our knowledge of the universe, but also on the future of space travel. Wrapping it up, the James Webb Space Telescope is changing space exploration. Its ability to discover planets, discover galaxies, and search for life marks a huge shift forward in our journey to understand this complex universe. The James Webb Space Telescope can look at the air around planets, which is an amazing and useful tool. The ability to view potential life so distinctly makes it easier than ever to assess various celestial bodies. These aren't just observations. Webb's tech means that scientists can compare planets with Earth and look for habitability on planets with similar characteristics to our own. Webb utilizes specialized microscopes that dissect the light from faraway stars and planets, giving scientists snapshots of the composition. This is crucial to determining whether a planet can sustain life. One of the most impressive functions of the James Webb Space Telescope, however, is its focus on the infrared spectrum, which it then turns around on dust-cloaked cosmic bodies such as stars or even complete planetary systems forming from the ether. These areas are often obfuscated for telescopes relying on visible light. The telescope's infrared and near-infrared also offers insight into the life cycles of galaxies and stars. The James Webb Space Telescope also has the potential to show us what the very beginning of the universe looked like. By studying light from the first ever galaxies after the Big Bang, scientists can discover new things about its origins and how it got to be where it's at now. The information gathered by the James Webb Space Telescope will be indispensable to the field of space exploration, and it's hard to even imagine the implications. In short, the James Webb Space Telescope is ushering in a fresh phase of cosmic discovery, and it uses all of its instruments to fulfill that mission. Another tool, NIRSpec, is great because it breaks down light into different colors. This tells us about the temperature, speed, and what the object is made of. It helps us look closely at stars and galaxies, figure out what's inside them, and how things interact. It also helps us understand how stars and galaxies are born, live, and die. One of the Webb's main jobs is to check out faraway galaxies whose light has taken billions of years to get to us. By looking at the light, we can tell how old they are, what they're made of, and other things about how they've changed over time. Then there's MIRI, which looks at longer infrared light. This is good for looking at stars, planetary systems, and those dusty spots where new stars are popping up. MIRI also lets us peek at the air around exoplanets to see what's in them, how hot they are, and if they could have life. Those star-birthing areas are really interesting. You can't see through the dust with normal light, but infrared can get through. With MIRI, we can watch stars and planets form and study what's happening inside those clouds. MIRI is also good at finding exoplanets because it can spot and study the faint infrared light from their air, telling us if they have water, carbon dioxide, or other stuff that could support life. When the Webb telescope is hunting for life on other planets, it mainly uses two tricks: looking at light, spectroscopy, and checking out the air around the planet. Even if a planet doesn't have plants or oxygen, that doesn't mean there's no life there. Spectroscopy is a big deal because it studies how light is soaked up or given off by something. When a planet passes in front of its star, the Webb can see the starlight shine through the planet's air. That light picks up tiny clues about what's in the air. The Webb uses MIRI for mid-infrared light and NIRSpec for near-infrared light. Together, they can see a wide range of light, which helps us get a good look. The starlight that goes through the planet's air tells us what the air is made of. The Webb looks for molecules that might mean there's life or that life could survive there. By finding these unique light patterns, scientists can make models to understand the planet's air and climate. One of the Webb's big goals is to find biomarkers, stuff that's linked to life, like oxygen, methane, and water. But finding them is just the start. We need more info to know if the planet is really livable and if there are any signs of living things. Another cool thing is comparing light patterns from different planets. This helps us figure out if there's a chance for life beyond Earth. What do you think about all this? Leave your thoughts below. If you like this, hit like and subscribe. See you in the next video. The James Webb Space Telescope can spot signs of life in the air around exoplanets, which is a huge step in finding life out there. It's got the tech to see planets super clearly. As scientists keep studying the data, they're learning new things about the chance of life on other worlds. The Webb telescope can look way back in time and see the early stages of the universe. By catching light from galaxies that formed billions of years ago, it gives us a peek at how the cosmos grew up. This tells us a lot about how stars, planets, and galaxies formed and how the universe became what it is today. Besides looking for life, the James Webb Space Telescope is also helping us understand space in general. It can take detailed pictures of galaxies, stars, and other cool stuff, which helps scientists piece together the story of the universe. With every new thing it finds, it makes us rethink what we know about the cosmos and what's possible in space exploration. The Webb telescope will change how we see the possibilities out there forever. It will keep being a key tool for exploring the unknown. Its discoveries could change how we see the universe and the future of space exploration. So, the James Webb Space Telescope is basically a turning point in space exploration. It can see faraway galaxies, find exoplanets, and look for life. It's got powerful tools and can do things we've never done before, so it's ready to shake up how we study space and show us the secrets of the cosmos. Checking out the air around exoplanets is one of the Webb telescope's most exciting jobs because it lets scientists hunt for hints of life on other planets. Its awesome instruments let us see planets and their air with amazing clarity. By finding key stuff that could mean there's life, like oxygen, methane, and water, the Webb gives us a way to tell if other planets might be home to living things. It's not just about seeing things, though. The Webb's tech lets us compare planets to Earth, which helps us figure out if planets with similar features could support life. It can break down the light from stars and planets to give us a snapshot of what they're made of. This is super important for figuring out if exoplanets have the right conditions for life and opens up new ways to study habitable zones in the universe. The Webb can also see infrared light, which means it can spot things we couldn't see before, like stars forming in dust clouds or planetary systems growing. These areas are often hidden from telescopes that use normal light. But the Webb's infrared powers let it see through the dust and show us details we would have missed. This gives us a better understanding of how stars and planets are born and grow, helping scientists learn about the basics of how the universe works. Plus, the Webb telescope can see both near and mid-infrared light, which opens up new ways to study the lives of stars and how galaxies form. Its instruments are made to study the light from galaxies, stars, and other cosmic objects, so researchers can figure out what they're made of, how old they are, and how they're put together. This will help us understand how galaxies grew, how stars are born and die, and how planetary systems take shape.